Hello everyone. Today we're going to go over one more gas law, which is called ideal gas law, which takes into account not only the pressure, volume, and temperature, but also the amount of a gas, which is the number of moles. And it's called the ideal gas, which is PV equals nRT. P is the pressure, volume is the V is for volume, N is for moles, R is a constant, and we'll go over it, and the temperature is in Kelvin.
The ideal gas constant, R, already contains the molar volume of a gas at STP along with the standard temperature and pressure conditions.
Okay, there are three values depending on the pressure. So if the pressure is in kilopascal, then you use the 8.31. If it's an atmospheric pressure, then it's 0.08. And if it's millimeters, then it's 62. We don't use that often, but mostly the ATM, but we have an example that uses kilopascal. So this, this is the first example. What pressure in atmosphere? So it has to be, I have to convert it. Well, 18.6 moles of methane exert when it is compressed in 12-liter tank at a temperature of 45. So we know the first thing we have to do is change the temperature to Kelvin. So we add 273 to 45. And then they want the pressure in atmosphere. So this is our R. R has to equal, the R we use is 0.0821. And that's the formula we're going to use. Now to solve, they want pressure. So we divide both sides by the volume. So nRT over volume equals the pressure. So we know moles. Moles is 18.6. We know R, which is 0.0821. And we know the temperature, 318. And we know the volume is 12. So we multiply everything on top and divide by the volume, which is 12, gives us 40.5 ATM. Okay. So as long as you know that moles is N, liters is volume, pressure is either atmosphere or kilopascal, and the temperature has to be in Kelvin, you're okay. Now, we have to be using the mass as well to learn the molar mass instead of N. So we remember from previous chapters that molar mass equals grams per moles. So moles would equal to grams divided by the molar mass. So N stands for moles, M is for mass, M is for molar mass. And then now we have to substitute. So now we have PV equal nRT. Now we know molar mass is grams per moles. And cross multiply, so moles times molar mass equals to grams. You divide both sides by molar mass, so moles equals grams per moles. And that's when you substitute N for grams per moles, grams per moles. And then instead, to put it in this format, instead of PV equals nRT, we have, we have PVM, which is the molar mass, equals to the mass times RT. Let's do one example. Determine the molar mass of an unknown gas. If the sample has a mass of 0.29 grams, occupies a volume of 148 milliliters at 13 Celsius, and the pressure is kilopascal. First thing we have to do is convert Celsius to Kelvin, so at 273. And then the next step is we know that the pressure is kilopascal, so this is the R we're going to use out of the three. And then the volume, we cannot use milliliters since our R has liters, not milliliters, so we have to convert the volume from milliliters to liters. There's 1,000 milliliters per 1 liter, so we divide by 1,000. to get to liters. So anytime you have milliliters, just divide by 1,000. Okay, and then this is the formula we're going to use. PV molar mass equals to the mass times RT. And then to solve for molar mass, because we want M, you divide both sides by PV. So molar mass equals the mass times RT divided by PV. We know that the mass is 0.29. We know our R is 8.31. We know our temperature is 286. We know our pressure to be 107. And our volume we just changed to 0.148. Multiply everything on top, 0.29, 8.314 times 286 divided by 107 divided by 0.148 gives us 43.5 grams per liter. We're going to have a lot of more examples to practice on your Teach Me and the handouts. Hope that helps. Thanks, everyone. See you next time.